we have minus 2, minus 4. So if we do minus 2 and then minus 4, so 1, 2, 3, 4. So here is minus 4, 0. That would be point L. We got K, which is 2. Okay, and then 3, 1, 2, 3. So that would be K here. And then M is 2, comma minus 2, so 2 and then down by 2. So that's where M is. Now if we're doing quadrants, this is quadrant 1, 2, 3, and 4. So K is in 1, L is in 3, and M is in 4. Okay, so what we need to do here is substitute our values. So I've already provided you all the x values, so you need to substitute your x into there and do the calculation. So 2 times minus 3, which equals minus 6, plus 2 will equal minus 4. 2 2's are 4, negative, positive, so that's minus 4 plus 2, that's going to be equal to minus 2. Minus 1, it goes in here, so 2 times minus 1 is minus 2, plus 2 gives me 0. Substitute 0 into here, so 2 times 0 is 0, plus 2 gives me 2. 1, so 2 times 1 plus 2 is 4. 2 2's are 4, plus 2 is 6. And then 3 into here, so 3 2's are 6, plus 2, which equals 8. Now before I draw the graphs, I'm going to work out this one here. Okay, so I'm going to substitute minus 3 into here. So 2 times minus 3 is going to be minus 6, but there's a negative out the front. So that's minus 2 times minus 3. 2 3's are 6, negative, negative is a positive. So 10 plus 6 equals 16. Let's do the next one. Negative 2, so 2 2's are 4, 2 negatives are positive. So 10 plus 4 equals 14. Minus 1, so minus 2 times minus 1 is plus 2. Plus 10 is 12. X is equal to 0, so that's just going to be 10. Okay, so that's now 1, so 2 times 1 is 2. So 10 take 2 is equal to 8. 2 2's are 4, negative, positive, so it's negative. So 10 take 4 is equal to 6. And then 3 2's are 6, minus, so 10 minus 6 equals 4. Okay, let's do this as a graph. So I'm just going to do mine on 2 separate graphs here. So the first x value here is minus 3, minus 4, so minus 3, 3, minus 4, 1, 2, 3, 4, and we do need to go up to 8, so 1, 2, 3, 4, that's another 8. Okay, minus 3 minus 4 is going to be here, 2 minus 2 is going to be here, minus 1, 0, so minus 1, 0, so it's no 0 on the y-axis. 0, comma 2, 1, comma 4, 2, comma 6, and 3, comma 8. So now I get my ruler and I draw my line of best fit. Okay, let's go to the next one. Now I've got my usual 3 to 3, but however I've got a value which is positive 16, so that means I'm going to need a fair bit of height. Okay, so just doing some preventative measures here. Okay, so that's going to be 3, that's minus 3, and that would be minus 3. 1, 2, 3, 4, 1, 2, 3, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the first one here is minus 3, 16. So minus 3 and 16. Next one is minus 2, 14. So minus 2 is here. Then 14. Then I've got minus 1, 12. So on the x equals 0, y is equal to 10. So that's there. 1, 8. 2, 6. And 3, 4. So now if I draw in the lines, line up my ruler the best I can, a little bit different on a tablet, and that would be my graph. Okay, in question number 4 here, so 3 people have different weights, had healthy BMI, body mass index of 20. So that's an approximate value. Again, everybody's body type is going to be different. So the heights were then measured. Okay, so what we have here is that we actually found 3 people with those weights. Okay, and then we measured their heights. So therefore the constants were the mass, and the variable, the thing that changed according to the masses, were actually the height. So the independent variable in this case will be mass, and the dependent variable, so it's dependent on the mass that you chose, is going to be equal to the height. Okay, so what we need to do is graph the mass and heights of 3 people and do a line of best fit. Make sure we use enough space. Okay. Alright, so I'm just going to get my ruler here, and by default I normally just go to the far left as most as I can and to the bottom. There's not going to be any negative values, so I don't really have to worry about that. Okay, now the maximum value was 60 kilos with the weights, so I'm just going to choose every 5 squares, 1, 2, 3, 4, 5 squares. That's going to be equal to 10 kilos. 1, 2, 3, 4, 5, 20, 1, 2, 3, 4, 5, 30, 1, 2, 3, 4, 5, 40, 1, 2, 3, 4, 5, 50, 1, 2, 3, 4, 5, 60, and a little bit more, 1, 2, 3, 4, 5, 70. Now, sorry about that. Now the maximum height we've got here is 1.73 meters. So you can just say, okay, right, what's a height that's going to fall within that limit? So I'm just going to pick 2 meters. All right. So all I'm going to do here is pick 10 squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be 1 meter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's 2 meters. So it actually works out quite nicely, and it fills up the space. Now for the first one, we have 20 kilos and the person was 1 meter high. So I go up to here, so there's my 20, go up to the 1 meter, and I put my point. The next one was 40, and it was 1.4 meters, or 1.41 meters. So 1, 2, 3, 4, and don't forget you can use a ruler. So if you can't go all the way across reliably, use your ruler to help line up. And then the next one was 60, so over here, and 1.73 meters. So that would be 1.9, 1.8, 1.7. So if I follow this line here over to 60, let's just double check, yes, and we've got our 3 points. So I'm going to draw my line of best fit here. Because this is going to help me answer my questions in part C. Okay, so from the graph there, estimate the height a 50 kilogram person should have. Okay, so if I've got a 50 kilogram person, we're looking at where that value crosses that line. So we've got 50 here. And then I'm going to use my ruler and measure across. So if I go up here and across there, then I'm going to read my value here, which is about 1.4, 1.5, 1.6. So I'll say that that's about 1.55 meters. Okay, so 1.55 meters. Alright, so what would the weight for a 1.2 meter person, what they should have? Okay, so 1.1, 1.2. So I'm going to draw my line across, and down we go, and it corresponds to a person with 30 kilos. Okay, so we're going across there and then reading the value off there, so we have 30 kilos. Now if I'm allocating marks, okay, so I'd be allocating marks, I would actually have 1 mark for the line, 1 mark for doing the line of the data points. Here would actually have the axis correct, so you would actually need a label saying mass in kilograms, and also another mark for this axis here, which would be height in meters, so don't forget the units. So that's where you'd actually get your 5 marks from. Okay, so solve the following linear equations graphically. Alright, so what we need to do is split these two up into 2 equations. So the 2 equations are going to be y is equal to x minus 2, and the other one is going to be y equals minus x, so y is equal to minus 2x plus 1. So I'm just going to draw a table for both. So x, y, x and y. Now remember the cheat, I just said choose the first one to be 0. So let's substitute my values. So first one I'm going to choose is 0, so if x is equal to 0, y is going to be equal to 0 minus 2, that'll be minus 2. Then pick another value, I'll pick something small so it's easier to graph. We've got 2 here, if I substitute my value in here, so 2 minus 2, that equals 0. Easy. The next one, if I substitute 0 into here, so it's going to be plus 1, and if I pick 2 again, just randomly, so 2 2s are 4, negative and a positive, negative, negative 4 plus 1, that's going to be negative 3. Okay, so now let's draw some axes. Alright, so let's draw the first one. So I've got 0 comma minus 2, so 0 comma minus 2. Now I'm just going to make this scale a little bit bigger because I've actually got the room, so I'm going to do 2, 3, minus 1, minus 2, minus 3, so that's 1, 2, 3, minus 1, minus 1, minus 2, minus 3. Okay, so the first data point we've got is going to be 0 comma minus 2, so 0 comma minus 2, so it's going to be down here, and then we got 2 comma 0, so 2 comma 0, and then I'm going to join those lines together. Now let's do the next one. I'll just change my color here. So I got 0 comma plus 1, so 0 comma plus 1, so it's going to be there, and my next one's going to be 2 minus 3, so 2 minus 3, and I'll join those lines. Again, a little bit more trickier on a tablet here. And then I'm looking for where it actually crosses over, which is this area in here, and that's going to be 1 comma minus 1, and that's my solution. Right, let's repeat the process again over here. So equation, so minus 2x plus 3, and of course don't forget to put a y at the front, silly Cavini. So y is equal to 3x plus 3. Let's draw a table of values. Let's go with x and y, we'll do the cheat, make the first one 0. So 0, 2 times minus 2 times 0 is 0, plus 3, so that's 3. What's another number we could choose? Oh, we'll pick 3 this time. Alright, so now we've got x equals 3, so 2 3s are 6, there's a minus, so minus 6, plus 3 is minus 3. 0, so 0 plus 3 is equal to 3. And what's another number? Ooh, we'll pick minus 1. So 3, now there's a reason why I picked minus 1, you'll see in a second. 3 times 1 is 3, negative, positive, negative, so that's minus 3. Minus 3 plus 3 equals 0. How easy is that? Alright, so let's actually rule this up. This time I'm going to make the divisions 2 squares for every division. Okay, so that's going to be 1, 2, 3. That's going to be 1, 2, minus 3. 1, 2, 3. And 1, 2, minus 3. Okay, so we'll use the blue for the first one. So I got 0 comma 3, so that's going to be a point up here, and I've got 3 comma minus 3, so 3 comma minus 3 is 3, down to here is minus 3, and I'm going to join the lines. So that's going to be our first line. Let's change color. Alright, so now I've got 0 comma 3, so 0 comma 3, and then minus 1 0, so minus 1 0, and I'll join the lines there. Didn't really have to do that because we knew that it crossed over there. So the answer for this one is going to be 0 for the x and 3 for the y, and that's it.